Stop approving forgings on the strength of a pretty test certificate. Reliable forging labs don't just give a certified reports, they document batch after batch. The raw spectrometer printout, the furnace time temperature chart with thermocouple IDs, and the actual hardness map across section. If you are not seeing those three, you are not seeing the truth. Namaste, I am Rahul Agarwal from Prestech Forgings and Engineering Private Limited. If you manage sourcing from automotive or agri machinery parts, your day is a constant juggle between price pressure, PPAPs, delivery dates, and the fear of a field failure sitting quietly in your pipeline. I have sat on both sides of the table as a supplier audits, customer escalations, and failure analysis. And I have learned one simple thing: quality is not about a certificate claims, quality is what the process can prove. Today, let's talk about the boring documentation that reliable forging labs repeat every batch and why it's your best insurance. Here is the hidden challenge: sample success, but the production failure. The pilot lot passes. 6 months later, a spindle cracks in the field or a gear loses its teeth. The supplier forwards a clean report, but when you ask for deeper evidence, the trial goes cold. No furnace logs, no microstructure photos, no operator qualifications, and the spectro results are typed, not printed from the machine. Root causes live in those gaps. Heat treatment drift because the quench was 12-degree warmer on a night shift. Chemistry mix up between two heats with near identical grade names. Magnetical particle inspection done but with an uncalibrated yoke or wrong technique. Tensile test values were okay, but the stress strain curve is missing, so yield was not estimated or not measured. Dimensional checks done with a wrong gauge and no R&R study. And when you challenge it, everyone blames the transport, the machinist, or the weather. Meanwhile, your brand carries the risk. It's emotionally draining because you did everything by the book: purchase order, drawing, certificate, and still something slipped. The uncomfortable truth: a neat certificate is the easiest thing to produce. A consistent audit trail is the hardest thing to fake. Most metallurgical failures I have seen are not about nominal chemistry, they are all about process evidence or the lack of it. The fingerprint of quality is in the unbroken traceability from raw material, heat number to the final part. The raw instrument output, not the summary typed into a template. The process conditions at the exact time your batch runs. If you only collect end of line results, you are measuring the lottery. If you collect in process evidence, you are managing the probability. That's the mindset shift. Here is a practical checklist you can ask for. What reliable forging labs document batch after batch? Even if you don't demand every item every time, make sure your supplier can produce them on request. Traceability: heat number, mill TC, and the internal batch ID linked to every operation and test specimen. Calibration proof: calibration due dates and certificates numbers for spectrometers, hardness tester, tensile machine, and furnace controllers. UT or MPI equipment valid on the test date. Chemistry evidence: raw spectrometer printout with sample ID method and any rerun notes, not just a typed table. Mechanical test with curves, tensile results including stress strain curve, yield method, offset or extension, elongation, gauge length, Reduction of area. Hardness mapping like multiple readings, surface, quarter depth and core with method maybe HB or HRC, load and locations marked on a sketch. Impact data, Charpy energy per specimen, test temperature, specimen orientation. Photos if fracture appearance is relevant. Microstructure photos, etched micrographs with grain size, face description. For example, ferrite, pearlite, bainite, inclusion rating if it is specified. Case depth for case hardened parts. Heat treatment record, furnace number, load diagram, part location, time temperature chart with thermocouple IDs. Quench medium type, bath temperature, agitation details. Forging process controls, preheat and finish. Forge temperature range, reduction ratio, die temperature, and lubricants used if they affect surface defects. NDT parameters, MPI, UT technique, sensitivity settings, calibration blocks used, operator qualification, acceptance criteria referenced. Dimensional inspection, CMM or gauge report with instrument ID and evidence of gauge R&R for critical features. Sampling plan and AQL, lot size, sampling rational match to the control plan or PPAP level. Deviations and kappa, any non-conformance, disposition and corrective actions with closure dates. Retention policy, how long data and retained samples are kept, who can retrieve them. Ask your suppliers to standardize this into a batch dossier. Even a lean version bundles enormous confidence. A North American agri-equipment customer faced intermittent hub failures during field trials. The chemistry was perfect, reports were clean, but the failures kept coming. When they reviewed the batch dossiers, the gap was obvious. No quench batch temperature were recorded after midnight and no hardness map at the core. The next night shift was topping up the bath late and the temperature drifted. Microstructure confirmed it. The structure was bainite where they needed tempered martensite. The fix was simple: continuous quench monitoring with alarms and mandatory 3-point hardness mapping per batch. Failures stopped. Nothing magical, just disciplined documentation revealing a small truth with big consequences. The big idea is stop buying certificates, start buying evidence. Reliable forging labs do not prove quality at the end, they demonstrate control throughout the process. If you adopt the batch dossier mid-side mindset, you reduce surprises, speed up approvals, and sleep better knowing the boring details are doing their job. Ask yourself, if a critical part failed tomorrow, could your current supplier produce and within 24 hours the raw spectro printout or the furnace chart, map, hardness map, and NDT parameters for that exact batch? If not, that's your silent risk. What is the one piece of batch evidence you will start asking for from next month and why? Share your thoughts. It may help someone prevent their next field failure. See you in my next video.